The problem is from GATE 2018 mathematics paper, question number 3. The problem given is, in the Lorentz series expansion of the function f of z equal to 1 divided by z times z minus 1, valid for modulus of z minus 1 is greater than 1. The coefficient of 1 divided by z minus 1 is, so it is asked the coefficient of 1 divided by z minus 1 in the Lorentz series expansion of the function 1 divided by z times z minus 1, which is valid for modulus of z minus 1 is greater than 1. The four options given are option A equal to minus 2, option B equal to minus 1, option C equal to 0, option D equal to 1. The NPTEL reference to solve this problem is Module 6, Lecture 3 of Complex Analysis, and the title of this lecture is Essential Singularity and Introduction to Lorentz Series by Dr. P.A.S. Sri Krishna. He is from Department of Mathematics, IIT Guwahati. Even you can watch this NPTEL reference video using this YouTube link. So now coming to the solution, by just looking at this problem, one can get confused that since it is asked the coefficient of this term 1 divided by z minus 1 in the Lorentz series expansion, one can think of that it is nothing but the residue of this function around z equal to 1, but that is not the correct. Since it is asked, it is mentioned that the in the Lorentz series expansion of this function valid for this region. So it is not the residue. Residue is also similar, which is nothing but the coefficient of the term 1 divided by z minus 1 in the Lorentz series expansion. But when you write the Lorentz series expansion about the point z equal to 1, but since here it is given the region is modulus of z minus 1 is greater than 1, it is not the residue. So, but if it is not the residue, then what? So now we'll see that what it is. It is given that f of z equal to 1 divided by z times z minus 1 for, and we have to write the Lorentz series expansion for modulus of z minus 1 is greater than 1, greater than or equal, I think greater than 1. So from this, since we can observe that region given that modulus of z minus 1 is greater than 1, yes, when we take this as a complex plane and this point as 1, so we have that series in that region mod z minus 1, modulus of mod z minus 1 is greater than 1, yes. So since it is 1, so let me assume this as the circle of radius 1 with the center at 1. Of course that circle does not, circle goes through the point origin, but since it is given modulus of z minus 1 is greater than 1, that so the region given is nothing but the outside of this region and even not on the circle, outside of this region in this circle, and not even on the boundary. Since if we take on the boundary, that is a point 0 at this the point origin, then we get modulus of 0 minus 1 is nothing but 1, but that does not, since it is given strictly greater than 1, that means the point does not lie, the point origin does not lie in this region, and one can observe here that why it should be like greater than 1 only, since at the point z equal to 0 it has a pole, so we should omit that point. So now how to write the Lorentz series expansion in this region? Since it is not given about the point z equal to 1, we have to consider in this region only, and since it is given mod z minus 1 is greater than 1, so it implies we can write 1 divided by z minus 1 modulus of z minus 1 is less than 1. One can see that easily. So now from this we have the function f of z can be written as 1 divided by z times z minus 1 as given. So this can be written as by partial fractions as 1 divided by z minus 1 minus 1 divided by z. Yes, right. Okay. So now from this can be written as 1 divided by z minus 1 minus 1 divided by z minus 1 plus 1. So why I am writing like this is since we have the term. So let me say this as some term which is okay. Let me write this as r. So we can say r is less than 1. So then in that case we have we can use the Lorentz, sorry, we can use the geometric progression as the sum of the infinite terms as a divided by 1 minus r. Or one can see the inverse. Okay, let me explain that. We can understand in between. So from this we can see 1 divided by z minus 1 minus 1 divided by. So I can take z minus 1 here outside. Then we get 1 plus 1 divided by z minus 1. So from this we can see f of z is nothing but 1 divided by z minus 1 minus 1 divided by z minus 1 times 1 plus 1 divided by z minus 1 whole inverse. Since from the given condition we can see that the modulus of. So okay, from this we can write modulus of 1 divided by z minus 1, which is nothing but the modulus of 1 divided by, sorry, which is nothing but 1 divided by modulus of z minus 1, which is less than 1. So from this we can see we can write an expansion for this term. That is why it is given the condition that modulus of z minus 1 is greater than 1. So now by using this condition we can write this as 1 divided by z minus 1 minus 1 divided by z minus 1 times 1 minus 1 divided by z minus 1 plus 1 divided by z minus 1 whole square minus 1 divided by z minus 1 whole cube plus some sum, which is nothing but the infinite sum of the geometric progression. So which can be seen as the first term as 1 and the common ratio is this thing. So from this we can see the entire term can be written as, when we multiply these two terms we get the next step as 1 divided by z minus 1 minus 1 divided by z minus 1 plus 1 divided by z minus 1 whole square minus 1 divided by z minus 1 whole cube plus and so on. This is in total 1 divided by z minus 1 whole square minus 1 divided by z minus 1 whole cube plus 1 divided by z minus 1 whole to the power of 4 plus and so on. Okay, let me write one more term here as 0 times 1 divided by z minus 1 plus. So from this is nothing but the Lorentz series expansion of the function f of z for mod z minus 1 is greater than 1. So now from this we can see that the coefficient of the term 1 divided by z minus 1 is nothing but 0. So the coefficient of 1 divided by z minus 1 in the Lorentz series expansion of is 0. So The options, out of the options, option C is correct. Thank you.